we have already, in the first lesson, in lesson one, we've already defined a number of things. We've covered the basics in terms of organic molecules, especially with respect to hydrocarbons. So I'm just going to mention a few things that we spoke about in that lesson that you have to know. You have to know the definitions of, because you're going to be asked these things in an exam. So you have to know those definitions. I apologize for my nose. It's that time of the year where you get your get my allergies. So the one thing you have to know, what is an organic molecule, know the definition of it. What is a hydrocarbon? We've spoken about all of these things. What is a structural formula? What is a molecular formula? As well as what is a condensed formula? And in terms also, in addition to knowing those definitions, you also have to know how to draw this or write down the structural formula, the condensed formula, as well as the molecular formula, and the general formula for alkanes, alkenes, as well as alkynes, right? So that those things are very, very important, especially for the first for carbon atoms containing a maximum of about 8 carbon atoms in their main chain, right? Okay, so now getting into this lesson, what is it that you're actually going to be focusing upon? So we're going to talk about Iupac naming. I'm sure this is not something that is new to you, but then we're going to talk about alkenes and alkynes, and you'll see why our discussion is centered around that. So I'm sure you might have noticed something. Let's start with a basic alkene. Let me just wipe this thing. So let us start with butene. So because the prefix there, so we start with butene. Oh, so yes, like I mentioned, let us start with butene, and this is applicable for all of them. It doesn't mean that it's only applicable to butene. I'm using butene as an example. So because of this prefix but, we know that it has about 4 carbon atoms in its main chain, right? And because of this, its functional group is an alkene, so somewhere it has a double bond, right? And then we can put the rest of the hydrogens there. Now this is a lie here, I'm lying. So remember, each carbon has to have about 4 bonds, 1 2 3 4, and I had drawn 5, so that was wrong. And then 1 2 3 4, that's fine. And we'll have 2 here, and then we can have 3 here at the end. Okay, and then I'm going to draw another structure in terms, and I'm going to move the position of this double bond. So let us move it. Let us maybe put it on the second carbon. And then here you have H, 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 1 2 3. We need another H there. Another one. That's enough. So how do we go about naming this? They are clearly slightly different because the position of the double bond is on a different carbon. So how do we begin naming them? So the important thing in terms of the Iupac naming is that the first thing, you have to number the chain beginning at the carbon, and that carbon, we'll call it carbon 1, nearest to the functional group. So here's a in this one, here is a functional group, right? So here is a functional group. It's that double bond thing, and then here is our functional group. So you have to look from either the left or the right, which carbon is nearest to the, if you start from this side or this side, which carbon is nearest to the functional group that we can actually call carbon 1. Clearly it's this one. It's because this one is like a number of 3 carbons away, so we can't call this 1. So we just say this is 1 2 3 4, right? Now let us come to this. I wish I'd actually drawn pentene, but it's fine. If we look here, it's an interesting situation. Which carbon, this one or this one, is closest to the functional group? In this case, you can see both of them are the same distance away from the functional group. So it really doesn't matter where we start. So we can say 1 2, 3, 4, right? Now the naming, we will still start to say, okay, it's 4 carbon atoms, so the prefix is still going to be but, and then we write dash there. Where is our functional group? It's at carbon number 1, so we write 1, a dash, and then we say in. So it's but 1 in. This 1 indicates where my double bond is actually positioned. It's positioned at the carbon 1. Let us do the same thing here. So we say but because it's 4 carbon atoms, and then we count 1, 2, 3. Our double bond is actually positioned at carbon number 2, right? So it's going to be but, that dash, and then it's going to be 2 in to indicate the position of this double bond. But this is the interesting thing that you have to know, that I'm sure you know. If the position of this double bond is at carbon number 1, we don't need to write but 1 in. We can simply just write it as butene. If either the double bond or the triple bond is at carbon number 1, it's not necessary to indicate that position there. Only perhaps when it's at carbon number 2 or 3 or 4, that's when we actually have to indicate with a 2, 3, or 4, right? I hope that makes sense. So now let us take another example. Let me see, we still have time. So I'm just gonna wipe this quickly. So now let us take pentene. It has pent means 5, so it has 5 carbon atoms in its main chain, right? And because it's pentene, we'll say that the double bond is at the first carbon. So let's do that. Quickly. Right. Okay. And now, using the information that we've described above, we can say 1, 2, 3, 4, 5. So we know we call it pent, it's its suffix. To indicate the position of the double bond, we can just write pent 1 in. But like I mentioned, it's not necessary if that double bond is at the first carbon, you can just call it pentene, right? It only starts mattering when perhaps the position of the double bond is at carbon number, let's move it to carbon number 3. So that double bond was there, and then say H, 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 H. Okay, so now we see that the double bond is not on the first carbon, starting from either side. So we have to start our numbering. Remember, we have to start our numbering beginning at the carbon nearest to the functional group. This is our functional group. So if you look at these 2 carbons there at the ends, which carbon is nearest to the function is nearest to the functional group? It's clearly this carbon, because this one you have 1, 2, 3, and this one you have 1, 2. So we actually start our numbering from this side. We say 1, 2, 3, 4, 5, right? So this means that our double bond is actually going on to be on carbon 2. So to write it, it's 5 carbons, so it's pent dash, and then you write the letter to indicate where your double bond is, another dash in to indicate that it's a double bond. So our functional group is that is a alkyne, right? Okay, so now let us move our discussion to alkynes. So we were talking about alkenes, now we're talking about alkynes. So remember, for alkanes, it really doesn't matter because you only have single bonds. So it still remains methane, ethane, and all of these other compounds, right? So now let us move to alkynes. So remember, alkynes, do we have those triple bonds between your carbon? So let us take pentine. So it's the same thing, 1, 2, 3, 4, 5, and let us put the triple bond there, and then 1, 2, 3, 1 H, enough, H, 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 H. If you don't know how to draw this, please refer back to the first lesson. I'm not going to go into detail about it, but the important thing is that make sure that each carbon has at least 4 bonds. 1, 2, 3, 4, 1, 2, 3, 4, right? So that's quite important. All right. So we start our numbering to the carbon nearest to our functional group. Here's a functional group, is alkyne. So meaning if we compare this carbon and this carbon, this is the carbon nearest to the functional group. So it's going to be 1, 2, 3, 4, 5, right? This meaning this is going to be pent because there are 5 carbon atoms. You draw your dash. It's the triple bond is a carbon number 1, so we call it 1. And then you for your functional group alkyne, you write this suffix "-ine", right? Okay, but then because it's at carbon number 1, it's not necessary for you to write it this. We can just say pentyne. So every time they say pentyne, you just know that the triple bond is actually at the first carbon. Okay, now let us move our bond to maybe carbon number 2, or the triple bond to carbon number 2, still using the same molecule. Remember, this is applicable for all of them. I just selected a few to kind of make examples, right? So you say C, 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 C. It's going to be 5 of them, and then let us put it here. That's where we have a triple bond. And then now let us draw our hydrogen atoms that are bonding with our carbon. So this is a hydrocarbon because we only have carbon and hydrogen atoms in the molecule. That's enough. So 1, 2, 3, 4, 1, 2, 3, 4, that's fine. Okay, so now how do we do this? We start numbering again. So we start numbering. Carbon number 1 will be carbon that is closest to our functional group. So our function is an alkyne. We have, and then the thing that makes it unique is that triple bond. If you look at this carbon or this carbon, so you always look at those carbon at the ends, either from the left or the right. So which carbon between this carbon and this carbon is closest to this functional group? So this one is 1, 2, 3 away, 1, 2. Clearly it's this one. So you start numbering from 1, 2, 3, 4, 5, right? And then how do we write it? So okay, our prefix is going to be penned because there are 5 carbon atoms. We write a dash because we're gonna write a number, and our triple bond is at carbon number 2. So we write 2, and then finally our our functional group is an alkyne. So the the suffix actually has to be "-ine", right? So you have pent to "-ine". This is applicable for all of them, for your alkanes, alkenes, and alkynes. So just make sure that you know how to kind of label them or number your carbons with reference to your functional group. We're still gonna do more example in the upcoming lessons, but I just wanted you to kind of understand and know how to do this thing. So now I want you to bring your attention to something very quickly. Okay, so what is it that I want you to bring your attention upon? So we agree that the position of your functional group there, the double bond for alkenes, is on different atoms. You can see here it's on number 2 and here it's on number 1. You know, if we started here, we started from this side, and then here we started from this side, right? So now let us write the molecular formula for this and this. So how many carbon atoms do we have? We have 5. How many hydrogen atoms? It's going to be 10. So it's going to be C5H10. Let me count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Right? So the molecular formula for pent1-ene or for pentene is C5H10. Let us do the same thing for pent2-ene. Write the molecular formula. So how many carbon atoms we have? It's 5. The number of hydrogen atom, it's still supposed to be 10. Let me just count them: 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's H10. So what are you noticing about these two structures here? The molecular formula is the same, but somehow the position of the functional group is on a different carbon. And what do we call those types of molecules? Those type of molecules, we call them positional isomers. So positional isomers refer to molecules where we have the same molecular formula, but somehow they are the functional group, or maybe the side of the chain, or maybe substituents are on different carbon atoms. For in this case, the position of the functional group is on different carbons, but the molecular formula is the same, and we call that a positional isomer. So I'm hoping that you know that definition, how to define a positional isomer. Okay, so now I want us to move our discussion to what we call alkyl substituents. Okay, alkyl substituent, right? If I write that entire thing, I'll take the whole day. Okay, so sometimes you have a chain, a main chain, let us say it was butane, and then somewhere maybe you find that you have another substituent, and this we call an alkyl substituent. And because this substituent has one carbon atom, we call it methyl. So meth, remember, coming from just one, and then thing that YL there, so it's called methyl. If the substituent on this chain, perhaps let me put it here. Okay, it's fine. If this substituent somehow had two carbon atoms, so it's almost as if it forms like a sort of a side chain. So we have our main chain, and then we have this side chain as well. So if it had about two carbon atoms, we'd call it, what is it? Ethyl. I'm lying, I almost wrote propyl. So it's going to be ethyl. So remember, F means two, and then YL is just because it's an alkyl substituent. And the thing continues. If there were three, it would be propyl. If there were four, it just continues forever. But then I think for you in terms of in metric, you only have to know about methyl and ethyl. But also, there's another important thing. Sometimes there's not just one methyl group. Maybe there's two. You find another side chain over there. If there's two, it would be dimethyl. If there was three, it would be tri. If there was four, it would be tetra. So those are just a few things that I want you to know. So we're talking about either methyl substituent or an ethyl substituent. If there's two of those, that thing, your naming will start with di. If there's three, tri. If there's four, tetra. So these are the substituent on which you have your main chain, and then on the side you also have those alkyl substituent. So now let us take an example so that we can kind of reinforce everything that we've just spoken about. So let us say we were given a structure such as this one. So you see in the main chain we have 1, 2, 3, 4, 5 carbons. So the main chain is always the chain with the longest number of carbon atoms. So we have 1, 2, and it also contains the functional group. So we have 1, 2, 3, 4, 5. It doesn't really matter, or you can say 1, 2, 3, 4, 5. You see that? So it still doesn't matter. But then let us select this chain as 1, 2. The longest chain is this one. And then remember we said carbon number 1 has to be the carbon close nearest to the functional group. So this is our functional group. It's an alkene. So we start 1, 2, 3, 4, 5. This means that these two will actually be now our alkyl substituents. So how do we start in terms of labeling them? So let's write our thing. So we know it's 5 carbon atoms in the main chain. It's 5 carbon atoms. So it's going to be pent. And then what's the position of the functional group? It's at carbon number 1. You can either write it or not. It doesn't really matter. So it's going to be pent 1 in. And because it's a double bond, then it's an in, right? And now we're looking at our alkyl substituent. On what position are they on? They are on carbon number 4, and there's 2 of them. So how are we going to write them? So we're going to say, so they're on carbon number 4, meaning we're going to say 4, 4, right? Dash. So between numbers and letters, you write a dash, di, because there's 2 of them, methyl pent 1-ene, or somebody will say 4.4 dimethyl pentene. So remember 4.4 because you have this substituent on carbon number 4 as well as this one on carbon number 4. So it's 4.4 dimethyl pentene, right? So that is just something important for you to know. The rules are mostly the same for all of them. So sometimes in a case where we didn't have this part here, so it would just be 4 methyl pent 1-ene, right? If we didn't have this second group here. And if this was an ethyl substituent, we would change to ethyl instead of methyl. So that is just something important for you to know. So before we end this discussion, I want you to, for us to just take a look at this example. So let's say we have butane, which looks something like this. Drawing these things is tedious, I don't want to lie. And then let me draw another compound, and there on the second carbon we have an ethyl substituent. So what's our longest chain is 1, 2, 3, or 1, 2, 3, and then on this carbon number 2 you realize 1, 2, 3. On carbon number 2 we have your ethyl, your methyl substituent, so it's actually methyl, right? So let us name this. So this one we know it's butane because there are 4 carbon atoms. This one, if we start numbering from this side, so it really doesn't matter whether we start on this side or this side, because this carbon, this your alkyl substituent, which is in this case is methyl, is still gonna fall on carbon number 2. Someone else might have said 1, 2, 3, but then you still see this would then become your substituent, which will still be on carbon number 2, right? So I hope that makes sense. So let us try to label this. So if we were to label this, what would it be? So we would say, okay, we see that the main chain has three carbon atoms, so it's propane, and it's only single bonds, right? So it's propane. And then on the second carbon we have a substituent, and it's methyl. So on the second carbon we have a substituent 2, so it becomes 2 methyl propane, right? So the chains of these two molecules look completely different. But now let us write down their molecular formula. So remember to write down the molecular formula. Count the number of carbon atoms, 1, 2, 3, 4. So it's C4. Count the number of hydrogen atoms, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's C4H10, right? The molecular formula for butane. Let us now write the molecular formula for 2-methyl propane. So how many carbons do we have? 1, 2, 3, 4. So still C4. The number of hydrogen atoms is 1, 2, 3, 4, 5, 6, 7, 8, 9. We know that doesn't make any sense to me. It can't be 9. So let's count again. It's start here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it's actually H10. So you're already noticing something. The molecular formula for both of them is the same. However, their chains look completely different. If you look at this chain and this chain, they look completely different. They are different. And what we refer to those molecules where the molecular formula is the same, but the chain structure is different. We call them chain isomers. So they have the same molecular formula but different types of chains. So remember, we've already defined positional isomers where our functional group was on a different carbon, however the molecular formula was still the same. And now we are now defining chain isomers where we say their chains look different but their molecular formula is the same. So let us finish this lesson here, and then in the next lesson I think we're gonna start talking about haloalkanes.